All right, for this next one, we have another polynomial function, and this time it lets us know that 1 plus 2i is a 0. Well, if 1 plus 2i is a 0, just a little side note, we also know that 1 minus 2i is a 0 because they're conjugates. So we actually know 2 zeros, even though they only gave us that first one. Since we're a 4th degree, we know that there are actually a total of 4 zeros, so we need to find them all. So if I was going to work on this, what I'm going to do is take this 0, 1 plus 2i, and do synthetic division. So I'm going to take all of my coefficients from the given polynomial, and since it is a 0, my remainder better be 0. So let's see how that works out. So I'm going to bring down my 1, multiply it times that. It's going to be a 1 plus 2i. Combining these guys together, I get negative 1 plus 2i. Then I have to multiply, and if I take 1 plus 2i times negative 1 plus 2i, because there's two terms kind of in those, when you multiply complex numbers, it's really a lot of distributing. So for the first part, I'm going to get a negative 1. Then I'm going to get plus 2i. Then I'll get a negative 2i. And lastly, I'll get a 4i squared. Now, with these complex numbers or imaginary numbers, I squared is equal to negative 1. So this is actually a negative 4. So you can see here, it's kind of cool, is that 2i and negative 2i, those will cancel. So we just have negative 1, negative 4. That gets us a negative 5. So multiplying negative 1 plus 2i times 1 plus 2i gets us negative 5. We combine these two guys together, we get negative 6. So then we're going to take that negative 6, multiply it times 1 plus 2i, and so just kind of showing my work down here, negative 6 times 1 plus 2i. This will just distribute, we'll get a negative 6, and then minus 12i. So negative 6 minus 12i will go there. Then we need to combine these together, which will make a positive 6 minus 12i. And then we're going to multiply that again. So we're going to have 6 minus 12i times 1 plus 2i. This one we have to do a lot of distributing. So 6 times 1 is 6. 6 times 2i is going to be plus 12i. Negative 12i times 1 is negative 12i. And then we have negative 12i times 2i is going to be negative 24i squared. Now again, since I squared equals negative 1, this is plus 24. And again, this is nice. 12i minus 12i, those cancel. We're going to get 6 plus 24, which is going to be 30. So we got 30 here, and woohoo, it does make my remainder a 0. So now that I have that, and again, I'm using this to try and break up my polynomial, what I'm going to want to do is take this kind of mess of a thing here, this, and what I want to do is do synthetic division with those leftover coefficients. And I'm going to use the other 0 that I know, which is 1 minus 2i, because its conjugate is supposed to also be a 0. So I should get a 0 as my leftover here. So let's work through this process. We're going to bring down the 1, multiply it. That's going to be 1 minus 2i. Combine these guys together. When we put those together, wow, everything cancels because you're putting together the real parts and then the imaginary parts, so we get a 0. Then we're going to multiply that. Well, that just makes 0. We get negative 6 here. Multiply that. That's going to be a negative 6 plus 12i when you distribute it. And yay, everything cancels, so we get that remainder of 0. And now the polynomial that's represented here, it's like, yay, all real number coefficients, which looks a lot better than all this stuff with 2i. But because we knew the conjugate also had to be a 0, it wasn't too bad. So the polynomial represented here, remember, it's your constant term, your x term, and then your x squared. So really we have x squared minus 6 is that polynomial that's left there. So we know that if I were to factor this, because let's see, the directions had said to find all the zeros. So I already know that 1 plus 2i is a 0, 1 minus 2i is a 0, and then since this is my leftover polynomial, I can set that equal to 0. And that ends up at 6 add 6, x squared equals 6. We square root, we get x equals plus minus radical 6. So there's my other two zeros. So all of my zeros, if I list them, are going to be 1 plus the 2i, 1 minus the 2i, a positive radical 6, and a negative radical 6. So those are all my zeros. And instead to write in exact form, that means don't plug that into your calculator and approximate radical 6. So then the next thing it wants to do, that's part A. Part B wants you to write f of x as a product of linear factors. A linear factor just means that it has an x, no x squared or anything like that. So I'm going to have 4 of these binomials, x, 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 and then I'm going to have, if you think about it, remember that if you had something that you factored, do like x minus 5, x plus 2 equals 0, then you'd say, oh, well, x minus 5 is 0, x plus 2 is 0, plus 5, we get x equals 5. So this is the 0 that corresponds to this factor. Minus 2, x equals negative 2. This is the 0 that corresponds to this factor. If you notice the signs kind of flip-flop like that. So if I know that 5 is a 0, then I can just write x minus 5. So if I look over here, since I know 1 plus 2i is a 0, I can just write x minus, and then I'll just leave it as 1 plus 2i. And I'll do that for these other ones as well. 1 minus 2i, and I'll put minus the radical 6, oops, and then minus the negative radical 6. But I guess you could just put this as x plus the square root of 6. So we have that going on. And then I would just leave these, not multiply out through the negative or anything. It's nice because you just look at it and you could see what your zeros are. Okay, so this is factored, and they're all linear factors. And then the last thing it said was it wanted you to solve the equation. And so if we know what the zeros are, and it wants us to solve the equation, it's really the same thing. So for part C, really it's just all of those things. Normally it will want you to write your answer here as a solution set. So you're going to put these little curly braces. Those mean that we have a set, and put our answers in there. So 1 plus 2i, 1 minus 2i, radical 6, negative radical 6. Or if you want to write a little simpler, you could put 1 plus minus, because we have a plus and we have a minus, the 2i, and then because this is a plus and this is a minus, you could also write plus or minus that radical 6. That works out too. So any of those are acceptable. I would normally write my answer like this, just so I could see 4 things. So hope that helps.